Live dot dot dot. This hangout airs live. Hey, anybody in pound tea time, can you tell me if you see me? I don't know if there's a delay either, so I will wait awkwardly for several seconds. I'll follow my own YouTube link as well.
Yeah, I'm on the YouTube link. I don't see anything.
um, well, should we be brave and just start, or what?
Yeah, I guess we should have somebody that says they're seeing it in YouTube, or else there's no broadcast to speak of.
Alright, I'll bring that back up then. Starting soon, dot dot dot. I'll follow
Hey,
my own YouTube.
I see you. I see you.
I'm on the YouTube link. I don't see anything.
It's working for me now.
Well, should we be brave and just start, or what?
I would say go, yeah.
Oh, I see it.
There's no broadcast to speak of. Great. I just closed the window to not.
We're on a terrible loop now. All right, cool. Well, I guess we're working. So, hey, everybody, welcome to Tea Time again. I'm going to take over for Rob. He's on crisis mode, I guess, so good luck, Rob. Go team. And we're going to start out with Paul. So, PBX, you want to take over?
Yeah, give me the share screen. Do that so I can. I think you have the power as the presenter. Maybe I can do it myself. Screen share. Hey, let's see. All right, I think actually I can do it right from here. So let's give this a try. There's the window, and tell Google Hangouts to use that. I'm sharing. All right, so do we see we fixed a bug in Agility?
I see it. I'm curious if YouTube viewers see it.
Right. If I see one confirmation in pound tea time, I will know that we're good. All right. Cliff is seeing it. So I'm gonna run with it. So this is something that I wanted to give a talk on this kind of as soon as it happened, partly because one of the perennial tea time talk ideas is to tell us what you're working on. Tell us what feature you built, or bug you fixed, or code you wrote. And I think part of that idea was to sort of keep people up to date on things so they don't trip over new code or features, or miss out on something that's rolling into the Medley code base that they could make use of. And I've always I've tried to goad people into doing more of those presentations, and so I figured I would do one myself on a bug that we encountered in interaction in Agility. So I'm just going to roll into it here and show you how it happened. This happened a couple months ago now, but we've skipped so many tea times that it just never percolated up. So here we are, and I'm going to tell you the story because it's still relevant, and I think I hope it's still useful. So we fixed a bug in Agility. What is Agility? Well, anyway, what's the genesis of this? We have a innocent-looking tier ticket, intangible. It's not a rush, deadline, hot prod fix kind of thing. We're literally just removing a field from the one of the models in Agility. Agility, if you don't know, is our homegrown application for managing ad units in Medley, and it has various models that keep track of that stuff, and then it talks to the ad system on Google's end with all that data, and it's constantly evolving, as is most of Medley. And one of the changes was this is mobile flag was getting pulled out. So there it goes. We're going to delete some very old Agility code, as the ticket says. And there are documentation. If you get interested in Agility, there's a whole rundown of it in there. But anyway, the players here are Agility, and then DFP, which is the Google service that we're publishing ads via, or getting ads from, and the parts of Medley that talk to all that. So we've got some code changes. This is just a snippet of the diff that was involved in this ticket. It was not a big code change. You see, here's a deletion. Remove the remove references to this field we're deleting. And so here's a couple where there was just a ORM query that used it, and we didn't need it anymore, and didn't want to throw errors by referencing fields that don't exist anymore in the model. And here's a string generation. I think it's a cache key generation. So just removing all references to this little ismobile field so that it's not cluttering up the code base because nobody uses it anymore. And there's some migrations involved, of course, because this is also removing the column from the database at the same time. Since we don't have it in the model, we don't need it in the database, so there's a migration that pulls it out. And so, hey, what? That's unexpected, but let's see what's going on. So our site throws 500s red bars on the very first try, and when we look at the traceback, I don't know if you can read this, but the bottom line of the traceback says values query set object has no attribute DFP add unit code. Now that's Greek to me on first reading and working with this code base, but it sure sounds like something got a kind of object it wasn't expecting, and I couldn't figure out how that could have happened given the code changes we made. So dive in, debug. Was the deploy bad? Did the new version of Agility not roll out with the new version of Mendeley? Because this is one of those where Agility is its own component, and it's got its updated version bumped in requirements.txt, but maybe that component build wasn't correct, or the Jenkins job didn't succeed completely, or whatnot, or maybe the migration was bad somehow, or maybe there was some crazy merge conflict resolution that created a crazy incorrect situation with the code out of a seemingly innocuous merging. So those are my first theories. Nope. It was bad data in the cache, and to their credit, a couple members on Interaction, Kerry Robbins and Dan Cobb, both suggested this early on after looking at the traceback and the code. And I basically poo-pooed it. I was like, well, I don't really see how cache could be a problem. And then I came back around to, after narrowing down everything else, that this was very likely the cause. So how did bad data get in the cache and get fetched by this thing that was trying to retrieve an add unit? Well, here's I just made a comment on the ticket, and I'm sure posting this to trace the narrative. That the data, I looked at the data that was there trying to be processed by Agility as an add unit, and it was a query set, and I thought that was funny because it was also an object that the Agility component uses, but it wasn't referenced anywhere in the code that I had touched and changed. PDB got me there, and by the way, just to pause there, also John Robinson and Andrew McMillan also both helped with the PDB on FE shenanigans. That's not a trivial thing to do, but they both helped me setting up PDB running against the live code on FE, because this problem did not occur on the VM. So this was something that had to be sort of debugged live on the FE. This is just a slice of a dpaste of the bad data, and looked at it, and gee, it sure looks like ad-related stuff, but even though it's nothing to do with the object that the code thought it was retrieving in this part of the app. So here's the fix, and the story was that in removing one of the places we removed that field was used in cache key generation. And if you go back, I sort of breezed over it because I didn't want to do a spoiler, but one of the code snippets I showed you a few slides ago included a change in string generation that was basically cache key generation that was using the ismobile field. That field went away, so we pulled it out, and that field was the difference between keys that were unique versus other keys stored by this app and ones that weren't. And so we basically had cache key collisions unknowingly, and this app was writing stuff into keys that were used in two different parts of the app and had previously been unique, but because we removed some entropy from the key string, they collided. So here's added a text test that says, are the keys truly doing their job? Does the keys different across the add unit and retargeting pistol were the two models that were implicated, and so we have a regression test that says that those keys don't collide, because sadly we had a number of cache key collision related bugs around this time, and so we got a little paranoid, and so put this regression test in to make just sure that it stayed that way. And I just wanted to thank Leland Nyman on the QA team who found this bug and told me, hey, we got 500, so that seems funny. Dan Cobb and Kerry Robbins, both who dove in immediately into the tracebacks and the code base and gave me the theory, which ended up being totally correct. And John Robinson and Aaron McMillan, who had the chops to guide me to setting up PDB on the FEs and SSH tunneling and whatnot, so I could actually get the data out that I needed. So that's the story of how we fixed a bug. I would love to hear more of these from other people if you all ever encounter bugs. That's the end. Thanks, you all, for listening, and thanks again for all the helpers on that one.
Yeah, thanks, Paul. That's awesome. Good job, Go team. Anybody have any questions on that? Oh yeah, and I see Connington Bear, so props to you for IRC PDB, I think it was.
Yeah.
Yeah, that's also cool. Totally use that in your production bugs. All right, I don't see any questions. How about, was it Tim next? Are you ready? And Isaac dropped off. I wonder if he needs a new link.
No, I'm still here.
Oh.
My camera was being silly.
Oh, you're all, okay, I gotcha. You're sneaky. All right, sorry. Tim, you ready?
I am ready.
All right, awesome. Go for it.
Okay. So is this showing up for the YouTube link?
Looks good my side. I don't have YouTube up though.
All right, well, I guess I'll just go ahead and get started, and if people on YouTube are having trouble, they can let us know in IRC. Okay, so this is man-in-the-middle proxy, and the operative word there is proxy, not man-in-the-middle. So this isn't a presentation about how you can go perform man-in-the-middle attacks on friends and family. This is a tool that I like to use in debugging, and it kind of coincides with a lot of the features that you get in your developer tools, but it does it at the network layer, or I guess at the HTTP layer. And it's just a generally useful tool. So what happens is you set up the proxy, so it's running on your local machine, and then you direct your traffic through it, and you can see the requests and the responses that are going through. And you can also do fun things like intercept them and modify them and write scripts that'll do the same thing for you. There's a forward proxy and a reverse proxy mode. There's a transparent mode if you want to do this at the TCP layer. So there's all sorts of fun things that you can do with this. So I'm going to give a quick demonstration of what this looks like. So I'm using a Chrome plugin called Foxy Proxy, and this just ensures that only the sites that I care about are getting proxied. So I'll check the options and make sure that we have the right things enabled. So check the URL patterns. And so the only thing that I'm currently sending through the proxy is the actual man-in-the-middle proxy website. So I'll go ahead and save that and close it. And so now, if I refresh man-in-the-middle proxy page here, we can see it in the background. So the request goes in, and then it makes subsequent requests for CSS. Let's make that a little smaller. And so I've been to this page before, so they're all coming back with 304 no content. So let's change that so that, and actually before I do that, put this keyboard up here so y'all can see what I'm typing. This is a Curses interface, so it's not really clickable. You have to use the keyboard. So using J and K to go up, and I'm going to go ahead and pull up the options menu with O and set anti-cache. And then when I refresh the page, it's now stripping out the caching headers, which is useful if you're trying to debug. Okay, so now let's look at one of the requests that has come in. So up a little bit. So I'll navigate down to the request I'm interested in, hit enter, and then I'll use tab to get over to the response. And now we can see what the response looks like. Okay, that's interesting, but let's intercept that. So go ahead and set a domain intercept for man-in-the-middle-proxy.org, and refresh the page.
I know. We got a man down. Please hold.
And a refreshed hangout. Sorry. Okay. So, refresh the page again. And you'll notice here that the...
Sorry, you're on video still.
Oh,
You,
you're right.
Cool, looks good.
Better? All right, I'm going to make this a little bit bigger because it's probably hard to see. Okay. And I just get rid of this old traffic up here. You'll notice that it's orange and the request is stuck. That means that we've intercepted it. And so we can edit if we want to change the header or the method. I'm not going to do any of that right now. So we'll just accept it. And now the response has come back, so it forwarded that on. Let's go ahead and edit that. Oh, we can't edit it because it's still compressed. So close that out and go through. And now I need to back out and accept all of these. Still going. Okay. So we need to turn off compression. We can do that here. And do it. And that's 2 fails in a row where I refresh Hangout. Really need to stop doing that. Okay. So I will refresh Man in the Middle again and let that one go through. If we go and edit it, it's no longer compressed. So, go ahead and change something here. So, change. Through, accept all the rest. Alright, and now we've modified the response. So that's interesting if you want to do this manually, but you can also script that sort of thing. The other place that interception is useful, excuse me, I'm sorry. The other place that interception is useful is specific request that you think is causing the timing issue, and wait to see if it's, you can deterministically let certain responses through. So that ends up being fairly useful. Let's talk about the scripting interface. So it's fairly straightforward. You have a script, and at the module level, there's a response and a request function. The flow is what you care about, and you can do things like replace a header or add a header. So that's adding a silly header. And I'll restart man-in-the-middle proxy. Add a silly header. This is terrible. There's all kinds of fail. Sorry, guys. Alright. The problem is that when I tab back, puts me on the wrong window. It's not the one that I was previously looking at. If anybody knows how to fix that, that would be awesome. Okay, so we have the script running, and it will add another header. So we have the intercept turned off now. If we look at this, I think that was a response header, right? So there we go. The auxiliary header has been added. So other interesting things that you can do with this, I think I'm running out of time here. But you can replace content. So I have a number of files that are sitting on the local machine, and using the pattern that comes with man-in-the-middle proxy. So back out. So when you're doing intercepts, or if you're filtering the requests that you want to see, there's different filter expressions that you can use, and you can combine these. So you can filter out the exact requests and responses that you want to look at and that you want to modify. And so you can use those in your scripts as well. So what the script is doing is on the request, it's turning off caching and compression. And then on the response, it's checking to see if any of those patterns match, and then replacing the content with the content from our local machine from the disk. And so let's go ahead and see what that looks like. I have an active flag. Just benefit. Should work. And I don't have Google running through this. Let's back it up. So now the response has been replaced with the contents of my requirements.txt file. So this is just a quick overview of the sort of things that you can do with man-in-the-middle proxy. It's a really interesting, useful tool. If you have any questions, I'd love to answer them.
I've got a question for you.
Sure.
What was the thing that drove you to find this and use it? What was the motivation to apply this to a problem? What was the problem you were solving?
So I think the first time that I ever used man-in-the-middle proxy was when I was doing back-end development for mobile applications. So I worked at a company where they developed iOS, Android, those sort of apps, and it could be difficult to see exactly what the apps were sending without going in and looking at the Objective-C or the Java code. And it ended up just being quicker to put the app on my phone, set up a proxy so that I could send all the traffic through and see exactly what they were sending. And then if I had a question about, okay, well, what happens if I send back this content? I can go ask the developer and they can spend a few minutes researching, or I can just modify the content and send it back directly. And you can do this on, you can do this against a production app. If you use the upstream proxy or the reverse proxy mode, depending on the situation, you can do something like take all of my AJC traffic, send it through the proxy, and send it to my local instance. and I just want to see what happens if I change this. So it just ends up being a pretty useful tool for. Sorry, I didn't actually answer the question. But yeah, that was the first reason that I used it, and I've used it in a number of cases since then. There was an issue on election day, this past election day, where there was a JavaScript error, and we couldn't figure out what was going on. I'm still not entirely sure what was going on. But I used this tool to replace the JavaScript that was going to the page with my own copy, and then I could poke at it and see what was happening in production without affecting anybody else in production.
Yeah, those are great examples. Thanks.
Thanks, Tim. Any other questions? Kind of all tabbing. I don't see anything yet. 5 seconds for more questions. 3, 2, 1. Well, thanks again, Tim. That's awesome. I'll have to look into that. Some sweet stuff. Isaac, you ready?
I'll go for it.
All right.
Can you hear me?
I can.
Yep.
Awesome. All right, I'll just go and assume that everyone is listening. So what I want to talk about today is WebSocket use with Django. So I got into doing this on my own, just out of as a learning experience. I wanted to try and experiment around with it. For anyone who doesn't really know what this is, a WebSocket is basically a way of connecting the browser or the client directly to the server with a long-running connection. So a way to think about it is it's sort of like an AJAX poll that is constantly going, but it doesn't use anywhere near the CPU processing that you need to do long polling with AJAX. It's just this open socket. And what's great about it is that you can basically use you can broadcast to every single client that is connected to your view. So it's a way of basically making a real-time application. So if someone does something on one client, you can update all of the other clients that are out there immediately with that new information. And so the idea being that it's sort of you're getting information out there more quickly, and it's a more like alive application. So I'll kind of get into the details now. That was just sort of the overview. So basically, I wrote up this blog post on my website. I use this to make some games, just sort of like interactive games where you can play against people. But I also posted this blog post on the site. The site address is Stroopic. That's the name of one of the games, stroopic.com. And then there's a blog link at the top. And so all of the information that I'm going to kind of go over is posted there, and you can see how to implement this. So this is basically implemented on a standard Django stack with Gunicorn and Nginx. And it runs using LiveEvent, which is a gEvent implementation. So I guess I'll talk about gEvent briefly. Basically, gEvent uses this sort of loop of little mini threads to basically process the socket. I don't know if that's a good explanation, but that's sort of how I understand it. So anyway, there is a repo out there called Django Socket.io, which uses which basically allows you to implement the Socket.io JavaScript on the client side and use just basic Django with an events.py on the server. There's a version of this in pip, but the one that's in pip is outdated. So I found someone who had forked it and made a more updated version that's basically the one that's in pip uses a version of gEvent that is broken, and so the one that the fork uses the more updated version of gEvent. So I have the address for the repo in here, and then I'll go into the next part, which is configuring Nginx. So basically, the way that it works is whenever the client socket sends a message to the server, it sends it with a URL suffix of socket.io. And so basically what I'm telling Nginx to do is to proxy any requests with that URL suffix to port 9000, which is where the socket.io server runs. The package that you're downloading, this Django socket.io, has this server already built for it, so you just run it. I'm running it using Supervisor, but you can run it just through whatever on the shell. So basically, yeah. So the server runs at 9000, and you proxy your requests to that server, and that server picks up all of the events.py files in all of your apps, and each one has its own namespace. So I'll scroll down here, and you can kind of see what I'm talking about. So you import the socket.io namespace, which is a base namespace class, and that basically defines a, for lack of a better word, it's like the name of your socket. And then within your socket, you have these different functions. So, for example, you have on echo, receive disconnect. This is a very basic one that just echoes stuff back and forth to the socket. But basically, the idea is that your client is connected directly to this file, for lack of a better way of explaining it. And when you will send from the socket. So I'll show you down here. You'd say, so you do IO connect, and then you connect to the namespace, which you define up here in your namespace decorator. And then you define a callback so that if your client receives something, it knows what to do. So you say socket on echo, and then call echo. So this one is just alerting the data that it gets back. But basically what's going on is by connecting to this echo, anything that you emit from the socket or to the socket can get broadcast to all of the different clients. So here's down here where I am describing a way to test this. So if you're on your client, you can do socket emit echo and then a string, hello world. So when you do that from the socket, like if you do that in the console of your browser on a page that's got all this loaded, it will actually call this on echo function, which then broadcasts back to all of the sockets that are connected. So if you have multiple browsers connected, multiple clients, they'll all get the echo that comes from your one browser console that emits it. And that's kind of cool. Having that's basically a way of taking information from one user and emitting it to all the users at the same time, which is not an easy task for the standard request response cycle of HTTP. So that's basically how it works. I'm sure there will be questions because I don't think I did a very good job of explaining all this, but does anybody have any questions?
I got a question for you, Isaac. What's your feeling about sort of adoption of this technology? What's it going to supplant? In other words, it's new enough that many people haven't dabbled with it yet, but when it's, support is good and understanding is good and library adoption is good, what's gonna sort of wither away?
Basically, Ajax. Ajax will this will supplant all of Ajax. It's just a faster way. It's a faster, more efficient way of updating clients, of having client-server communication that isn't bound to that request-response cycle of the client sends something, the server does something, and sends it back to that client, and you have to have the callback, so it can only refer to that client, right? Whereas now you can have your client call to the server updates all the other clients at the same time, and then responds back to the original client. But there's no like call and response. It's all just it's like a messaging protocol. I don't know if that answers the question, right? But it's basically like it's a way of it's sort of like, for example, to use a Facebook analogy, it's like what happens when you click like on something and everyone else who happens to have that like content sees your like immediately. They're doing that through this sort of complicated Ajax nonsense, which is super inefficient. It's the same process, but it's like way, way, way cleaner and much less code and much less overhead.
Great, no, that's a good answer. And there's your clickbait blog posting title, "This Will Kill Ajax."
Yeah. Huh. Any other questions?
I have a question. You said you used it in some sort of game stuff or some sort of game application. What was your favorite usage of it, or was there anything notable?
So I built a little. I built two things. One was this game that I kind of invented myself, which is basically like a Stroop test, which I don't know if you know what that is. It's like a psychological thing where you show a word that says a color, but the color of the text is a different color. So like it'll be the word pink, but the actual letters will be red or brown or something else. And so this is just like a timer to see how fast you can answer it. And basically the idea being that you could compete against multiple people playing the game at the same time. That was the first thing that I played around with. Then I built a little ping pong module so you can get two people in sort of a room, and a room being a namespace. You can have two people connected to the namespace, and they can play ping pong against each other.
Nice, awesome.
So yeah, like I said, all that stuff is available on that website that I mentioned before. I can spell it again. It's Stroopic, STROOPIC.com, and you have to register like a name because it needs to know basically who you are in order to keep track of the sockets and just to know stuff about you. But yeah, feel free to go there and check it out.
Cool. We did have a question from DataGrok. So there's a Django server on port 8001 and a separate server for Socket.io on 9000 that has access to the same Python modules. Does a Socket.io server have the ability to do things like use Django's ORM?
Yes, it does. Well, I should qualify that. Everything that flows to the socket flows through events.py. You can import and talk to other parts of the Django app through events.py. It isn't the sort of thing where like you could say like here's an example of something you can't do, right? You can't go into the shell on your server and update a model and have it send that new model to the new sockets because it needs to get some kind of ping going into events.py first. I should actually also qualify that. I'm not actually sure that's not true, but I could not figure out a way to do it. There's not a lot of good documentation on this, so I kind of had to poke around to find stuff. But I couldn't figure out how to make that work, but there may be a way. As far as I could tell, all of your interaction with Django is through events.py. But that's just like a regular. It's just like a regular Py file in an app, and you can import and export any functions or things like that you want. And events.py can update models, and you can take you can have information coming in from the socket to update a model, and then on that update you can send the new update out to all the other sockets. I don't know if that fully answers the question.
I think so, yeah. Thanks.
No problem.
Cool. I don't see any other questions, so I guess that about wraps it up. Thanks, especially to the presenters. And I guess we'll see you in 2 weeks, hopefully, cross my fingers. All right. Bye, everybody.